Well, now I have work on my spare time on this um, kind of like toy um, out of random components I have found in the last month. One of them is this, I think it's a Hot Wheels kind of racetrack, and I got more of that on that chair. But the cool thing is that it looks like FlexLink, like a conveyor linkage system, like the professional one. I have a Raspberry Pi here. I have an Arduino Nano, and I have a MeArm 4-axis robot um, system. And as the uh, gear motor for the conveyor, I have a coreless drill motor and gear reducer that I removed the chalk from, and I designed it in AutoCAD, and then use my 3D printer to print a sprocket that will interlock in the um, conveyor, linkage, flex link, whatever you want to call it. And also designed this round pieces like conveyor guides that you can adjust to have different tension on the linkage. I cannot put a lot of tension in it because it will snap off. So it has to be a little slack on it. These here and that there are custom made um, prototype boards, proto boards that I've designed. One of them is got a MOSFET and an optocoupler, so I can control the pulse, the duty cycle using pulse width modulation on the gear motor here, the driver motor for the conveyor. And another one is a relay that will power on or enable the servos. There's a dedicated 5-volt power supply for the Raspberry Pi and the servos. So this relay here cuts power to the servos, so they will not be running while the robot is idle. Also, there's a photo switch back there, an infrared one. I don't know if you can see the little infrared light coming out. I don't see it, but you can see it through the cell phone. So this is a infrared photo switch, reflective type, and that's pretty much it. It's got the Raspberry Pi. I got the Raspberry Pi connected through the Ethernet port to my laptop here, and I have a simple program that I wrote, which is simply the first thing I do is I import some libraries, GPIO, serial, and time. Set my pins. You know, the Raspberry Pi has got this Raspberry Pi 2, 3, and 4. It's got this pin layout. So I'm using some of those pins as outputs and input. One of them is a pulse width modulation for the motor, the conveyor. And then I have this list of tuples of servo angular position. So this is the program kind of that is sent to the Arduino Nano. So the Arduino Nano then parses these values. So this is sent as a single line of text, except for the delay and the text line. These 4 values are sent to the Arduino a line at a time, and then the Arduino parses that and then selects, this is join 1, join 2, join 3, and the gripper, or join 4, and then follows this step. And this here is a, sorry, it's a dedicated, it's just a function that I call here, down here. This is the little function that I wrote. So you just call that function robot motion and pass all the 4-axis joint positions, and then a delay, and then a message that it will be prompted, and it will send a value to the Arduino, and it waits for the echo back. So the Arduino will reply with the values. So just make sure the robot move to the designated position. And down here is the main loop, which is I define the frequency and duty cycle of the conveyor, and then start my pulse width modulation on the conveyor, and then execute. And I wait for a part to be present at the photo switch here, and then I stop the conveyor, and then I enable the servos on the robot. Then I wait for 1 second, and then I execute my pick program, and then my drop program, and then I disable the servos, and then it loops back. So that's pretty much in a nutshell what it does. So let me just exit Nano here, back into the terminal here. I'm going to execute Python program here. So this is a part, an object that I try to pick up. So once I execute my program here, let's see, the conveyor starts, and it will wait for the robot to go back to home, grab the part, go and restart the conveyor again. And the text messages are displayed so you know what the robot is doing. And if I put the part again in place, and like I said, the conveyor starts and the robot is disabled, so the servos will not overheat. And I'll do is place my part again. And that's pretty much it. I can add more sensors. I can add a stack light. I got a 3 volts to 5 volts bidirectional converter, voltage converter, so I can add these 5 volt sensors to the Raspberry Pi. I'll put my another part. Now there's a relay that disables the servos. And like every part, I'm just gonna cancel the program now. So all these parts, the parts that I employ, like below here, I run the cables, the power cables. There's 12 volts to drive this motor here. Also this relay. There's 5 volts for the Raspberry Pi, the servos, and this is the Ethernet cable. So everything runs through that hole. So because I got a conveyor around it. And down here I have this little legs that I printed, and I just they just allow me to run the cables under the plant. This is the plant. This controls engineer call this is the plant. All the little parts that I have here, there's the legs for the MeArm robot, where I designed them in AutoCAD and printed it with PLA on my Delta printer. And then also the sensor bracket was also designed in AutoCAD and printed. And this here is a multi-part bracket holder, or whatever, mounting for the gear motor. Everything was designed in AutoCAD. And those tiny parts, I already have several of those that I printed, just like cable clamps or whatever you want to call those. So the idea here is to experiment with this, add sensors, and probably, if possible, I can add a HDMI, a touch screen, and probably have a kind of a HMI, maybe, I don't know. But this is the goal, is to have this kind of like experimental automation using Raspberry Pi and Python. So this is free, cheap. My goal was to not spend a lot of money. Use whatever I had at hand already in house. So everything, I never didn't buy anything. I already have everything. All I did was trying to be creative and use it wisely, and I'm pretty pleased with the result. Well, I'll try to, if any of you are interested in the source code, I'll probably can find a way to share it. I try to use GitHub, but I have some trouble with it. Maybe I can upload it to other, like Google Drive or something, in case someone is interested in the source code or the AutoCAD files for all these parts. I really don't know if this is Hot Wheels or not. I'm really looking for a logo in it, but I don't know if it's Hot Wheels or not. But it's kind of like a racetrack for cars, for toys, or, you know, not really sure. But whatever I design it, I can share it if someone is interested. Well, thumbs up if you like the video, and stay tuned for more.